Washington State University. Go Cougs!
Hello and welcome back to the course on statistical inference. We're in Module 1 where we're giving an introduction to statistical inference, and in Part 2 of this module we'll be looking at the scikit-learn library for doing statistical inference methods. So in this snapshot of the homepage for scikit-learn, we see that it has several different capabilities. And we've talked about most of these. It offers several methods for doing classification, which is predicting a categorical class value, for regression, which is for predicting a numeric class value, clustering for looking for major trends or subsets of data that are similar to each other, dimensionality reduction, which is if our data is very highly dimensional, we may want to reduce that or project it down to fewer dimensions. Model selection is essentially evaluation, where we're evaluating the models to see which model is best for the data we have. And also various types of pre-processing, feature selection, feature extraction, normalization, scaling, and so forth. So we'll be looking at these over the duration of this course. But for this part, we're just going to look at the general process for applying scikit-learn to a statistical inference task. So the general process that we will be using is to first, of course, we need to import data into the Python environment, import the methods from scikit-learn that we want to use. We then fit the model to the data. And typically we then use that model to predict the values of the data or of separate test data. We apply various evaluation metrics to the model. We won't be doing that in this part, but we will see how to do that later once we have more different methods, more familiar with different methods. And then lastly, we typically want to visualize the results so we can see and use a more of a visual analysis of the data. So let's go through this process for a simple example. First step is to import the data. Now in Python, hopefully you're familiar with Python and know that the list is one of the main data structures in Python. And so one way to represent the data is in a list. So down here at the bottom I have a snippet of our sensor data that we've collected, and the features are typically everything except the class. So our class is the activity, what we're trying to predict, and the features are the different values for the sensors. So typically we would put these sensor values into a list, or if we are having several examples of sensor values, then it would be a list of lists. Now, scikit-learn, kind of underneath the hood, uses a data structure called a NumPy array, which is more optimized, especially if you have a large amount of data. Now, for the size of problems we'll be dealing with, we could really use either one. We won't see any difference in efficiency. But as your data sets get larger, you will want to represent them as NumPy arrays from the beginning. Likewise for classes, we can also use list to hold the class values for each of the examples. And also we can use a one-dimensional NumPy array to do the same. Lastly, the data itself is going to be in some format. The format we are using is the CSV format, which stands for comma-separated values. So as you can see, the file that holds the sensor data is basically each row is a collection of the sensor values, and those are separated by a comma. The Python has a module for importing CSV files, which makes this format very easy to deal with. So that's a fairly typical way to represent the data you want to import. So as part of the materials for this course, you have a Python program called readdata, and I want to show you what's inside the readdata file, which is where we're going to import the data. So at the beginning of the file, we are importing the CSV module or library, which gives us the tools to read the CSV files very easily. And we're going to store each of the values, our class values and the feature values, into these various lists, which are initialized to be empty. So all of the activity classes will go in the activity list, all of the yaw values will go in the yaw list, and so forth. Then in the second half of this Python program is the actual function that will read the data. So we define this function called readdata. It opens our sensor data CSV file and then reads each row of the file, skipping the first row because that's just the header names. But then for each subsequent row, it takes the particular element of the row and appends it to the list as appropriate for that feature name. So after calling this function, we will have read in all of our sensor data, and it will all be stored into these different lists. So now let's look at an actual example of applying a scikit-learn model to our data. In this example, we're going to do a simple linear regression between the x and y accelerometer values. And this linear regression model is described at this website if you want to learn more about the theory and the different parameters that could be set. But let's run through this file real quick and then we'll see it in action. Now you can see the first line here, we're actually importing our read data file, and so what this does is it allows us to keep that those auxiliary functions in the separate file. We load them in as needed, and then as you can see here, we use this construct of the module name and then the dot and then the function or variable name that we want to access. We're also going to be visualizing our results, and the matplotlib library is the standard visualization tool suite that's used by Python and scikit-learn. So we're loading that in, and this construct here as PLT is just a way for us to give it a short name so that it makes our code a little bit easier to read. Lastly, we're going to be importing from the scikit-learn, which is abbreviated as sklearn. And instead of loading the entire library, we're just going to be loading in the models that we need. And so from the scikit-learn library, we're only importing the linear models. So this reduces the amount of code that we're loading in. Okay, so now that we have everything loaded in, we can execute our program. Again, the first thing we do is call that read data function that we just looked at, and that will load all of the data into those various lists that we saw. Now, the linear regression model has the capability of handling multidimensional data, but in our case, we just have one-dimensional data, the x values and the y values. Each of those values represents a one-dimensional array, essentially. But because the linear regression allows for multi-dimensions, instead of just getting a list of values, it actually expects a list of lists. And so what we're going to do is convert each of our individual floating point values to just a list containing that value. And one way to do that in Python is to use the map function. So what the map function does is it takes each value from our list, in this case our acceleration x values, and it converts them to whatever we want. So in this case, the x will range over all the values inside acceleration x, and for each of those values we simply want to convert it into a list of that value. And then we'll do the same thing to the acceleration y values. Now, just to show you that in a little more detail, I'm going to jump out of the slides here and go into a terminal window so you can see a little better what's happening here. So here we are in a terminal window. I'm going to start up Python. The nice thing about Python, of course, is that you can start up an interpreter and try out some of these things. So let me just create a list, call it acceleration values, and put the comma in the wrong place there. Okay, so now we've got a list of floating point values. Let's pretend that those are our x acceleration values. And then to show you what happens when we do this mapping function. So lambda is just kind of a traditional name for a generic function. So we're saying we have a generic function. It takes an argument x and it returns a list consisting of x, and then followed by a comma, and then the lists that are going to provide these argument values. In this case, we'll just pass in our acceleration list. So here's the result. You can see that it's now each of those floating point values is wrapped by another list. And again, we're doing this because this is the format that the linear regression requires. So let's go back into the notes. So we have our two dimensions that we want to learn a linear model between. So let's actually fit that model. So first we're going to grab the linear regression linear model. There are some other linear models available, but we'll use the linear regression one. And then we fit that model to our data. So again, we're passing in the x and the y data to fit this linear model. And then lastly, we're going to use that model to kind of repredict our data. So in this case, we're using the same x values, but we want y to represent the predicted y values, not the actual y values. And that way we can see how they compare to the actual y values. So you can see that going on over here. This is a window we're eventually going to pop up where it has the black dots here are the original data, and then the blue line represents the predicted value over this data range. So you can see it's pretty close, but it makes some mistakes, which is typical for linear regression. Now, how do we get this plot? That's the second part of this program down here, where we're going to be using the matplotlib library. First, to plot all of these dots, we're going to use a scatter plot. So our first step here is to add a scatter plot to our plot. We're going to plot the x and y acceleration values, and we're going to color them black. So that's where we get the black dots. Next, we're going to use plot, which is a line, and the x and y values of that line are the original x acceleration values, but now we're going to be using the predicted y values, which will all fall conveniently on a line. We'll give it a color blue, and we'll make it a little bit wider so we can see it very clearly in our plot. Lastly, we'll add some labels to our plot. We'll give it a title, and we'll label the axes so that we can understand what the plot is showing us. And finally, we would actually show that plot, which would then pop up a window on the screen. So to execute this, we would just type Python and then the linear regression.py, which is the file that holds this program. So let's go back out to our terminal window and see that in action. So I'll get out of this Python interpreter. You'll see that I'm in the source materials directory here, which for now just has our read data, our linear regression, and our sensor data. And they're identical to what you saw in the notes. So let me go ahead and run the linear regression program. Of course, that reads in the sensor data, and then it produces this plot. And so there's our linear regression of between the x and y acceleration values. Now, one other thing I want to show you about generating the plots in this way is that this is an interactive window. So I can do things like, if I click on this magnifying glass, I can choose a rectangle, which it zooms in on. I can also choose this arrow, and that allows me to move around using a left click, or if I right click, I can zoom along different axes based on just sliding the mouse around. And whenever I want to get back to the original, I just hit the home key. So that gives you a little bit more tools, visual tools to inspect your data. It's especially helpful if you have three-dimensional data in order to rotate around and see different views. Okay, bring the notes back up. So that pretty much completes our first example of using scikit-learn to do statistical inference, where we've simply looked at a linear relationship between two of our features. So in review on this module, we started out talking about what is statistical inference and talking about the different types of data. We have features and classes, and those can be categorical or numeric. We also talked about the different methods, and that is primarily what we'll be focusing on in the rest of the course. But for now, in this part, we just looked at a simple example using linear regression. And again, the main tool that we'll be using throughout this course is the scikit-learn library. So that completes the first module. And in the coming modules, as I said, we'll be looking closer at the different methods available within scikit-learn and trying them out.